Welcome to this talk at Open Community for Java. My name is Ivar Grimstad. I'm the Jakarta EE developer advocate at Eclipse Foundation. And I'm going to talk about why Spring matters to Jakarta EE, or why Jakarta EE matters to Spring. So if you want to follow me on social media or connect with me after the talk, you can find my coordinates here. I'm on most platforms. I'm a Java champion, and I'm also involved in the Apache with the NetBeans project, and I run a Java user group in Malmö in Sweden. So, you didn't expect this one, right? But this is true, and we'll get to it. And you can turn it around, because it goes both ways. We like each other very much, and we depend on each other. And we'll see how it goes. But what I want to do first is just to take you through a little timeline of history. So if we start in 1995, who was born in 1995? Yeah. Or after 1995? Okay. So Java is almost 30 years old. Next year is 30 years old. So it's been around for a while. And Java was intended on devices. On tablets. That's where they created it for, to create UIs on tablets. But it turned out that it was very good for server side, and it was very quickly adopted on servers, and J2EE came along in '99. And J2EE has been a tremendous success. That is what's powering the world. Like all financial transactions, everything goes through J2EE. It's a super success. But it was a little, you might say, over-engineered. And in 2004, Spring came out, and Spring kind of addressed some of those things by making it a little bit simpler. And Spring has kind of taken over after that. But around, in 2006, Java EE kind of saw what Spring was doing and say, hey, this is kind of cool stuff. Let's do it and do it better. So Java EE came around in 2006, and with Java EE, it started catching up with the dependency injection, the annotation-based approach, and where Spring was still in the XML configuration space, Java EE went along with the annotation-based. So JSR 330 came along, and that was led by the Spring folks that wanted to have dependency injection for Spring. So that came in 2009. And then in 2013, Java EE 7 came, and around that time, Java EE had more or less caught up with Spring, and I think it was even better platform than Spring at that time. But of course, Spring Boot came in 2014, and that has been a success story since. Jakarta EE came along in 2017 when Oracle moved it over to Eclipse Foundation. And it's been there as an open source since 2017, and we've done the namespace change in Jakarta EE 9 in 2020 that kind of disrupted the community a little, and we're now doing a Jakarta EE 11 release coming out later this year. So we've done from Java EE 8 back in 2016. And Jakarta EE 8 coming out in 2019, we've done a 9 release and 10 release, and now 11 is coming. So it's kind of a 2-year cadence we're delivering the Jakarta EE platform. So that was kind of a look back on how these frameworks have kind of danced with each other, if you like. So the current release of Jakarta EE is Jakarta EE 10. It came out 2 years ago. And to talk about Jakarta EE, it is all about specifications. Like, the Spring is a framework. Jakarta EE is about specifications. And specifications in Jakarta EE is a specification document, a human-readable text that you can kind of find as a PDF or HTML. And it's an API that you will find in Maven Central that you would use as a developer. And it's a test compatibility kit, or a TCK, that we use to validate that an implementation fulfills the requirements of the specification. And once it passes the TCK, it's a compatible implementation. And we need at least one open source compatible implementation in order to ratify a final specification. And there are lots of specifications in Jakarta EE 10. And all the blue ones here were updated in between 9 and 10. So as you can see, it's more than half of the specifications were updated in some form or the other. Some of them weren't updated. That doesn't mean they're not relevant or anything. They will be updated maybe in the next release. So they're good as they were for 9. We also added one new specification, the CDI Lite, which is actually a kind of a lie because it's not a new specification. It's just a subset of CDI. But we like to balance a picture like this because CDI Lite is what gives the Jakarta EE the possibility to compile to native. So the subset of the platform is the Jakarta EE web profile. And the web profile is targeting the more traditional web applications. And it's kind of comparable to the Spring framework. If we look at the core profile, that was new in 10. So this is the first time we introduced a new profile since Java EE 6. And the core profile is targeting RESTful web services or microservices, if you like. And this is where CDI Lite is an important part, since it enables smaller runtimes to use the GraalVM to compile to native, if you want to. You don't have to. Jakarta EE 10 is based on Java SE 11, which may seem old. But what we make sure is that the TCK runs on 11 and 17, and we also have compatible implementations that are passed on 21. So we support all the newer versions, but we also maintain the backwards compatibility so we can run on 11 because some people may want to do that. But as app developers, you can use 17 features or 21 features even. It just depends on what your implementation supports. So how is this relevant to Spring? Well, Spring builds on Jakarta EE in very high degree. And if nothing else convinced you about that, it is the Jakarta EE 9 release. And when Jakarta EE 9 release came out, it had one change. And one change only, and that was we switched the namespace from javax to Jakarta. And it was a reason why we didn't do anything more than that, because if we have changed the API as well, you would probably still be struggling with migrations. But since we only did the namespace, we wanted to make that migration as easy as possible. And I think many people are helpful for that. So that release was all about the namespace, and if you didn't think Spring depended on Jakarta EE, you just look at javax or do a migration from Spring Boot 2 to Spring Boot 3, and you'll figure it out. And this namespace can switch if you want to migrate. Can be easily done in your IDE. Most major IDEs have support for it. Like IntelliJ here, for example, you can migrate from Java EE to Jakarta EE very easily, one-click refactoring, and your namespace change has been done. And the other IDEs support that as well. You can use Open Rewrite, and there are lots of recipes out there for Open Rewrite. And you can actually use the Jakarta recipes for a Spring application. There are also recipes for Spring specifically, because the migration from Spring Boot 2 to Spring Boot 3, or Spring Framework 5 to 6, is more than just the Jakarta namespace. They also had some breaking changes. And there are Open Rewrite recipes for that as well. Or you can create your own company internals. So I just want to do a quick demo, because what we did in 9 was also to create some tooling around this. And when I've done talk in the Spring community, they are, even though they have probably done the migration already, they see that, oh, I wish I knew about this tool. And this is all about the upgrading of the transitive dependencies in your application. So I'm going to show some code where I have a Spring Boot 2 application that has a dependency. And this dependency has a transitive dependency called dukelib. And when I want to change that application over to Spring Boot 3, I not only need to migrate the application itself and the dependencies I have on it, but I may have to do something with the transitive dependencies as well. And for the dependencies I have the source code available for, that's easy. I can just use the migration tools in the IDE or Open Rewrite, or just do it manually. The problem is when I don't have the source for the transitive dependency. It can be libraries or whatever that I, for some reason, don't have the source for. So let's look at the code first. So I have this Duke Boot application here. It is a Spring Boot application. I have done some of the migration steps because we don't have time to do the entire migration, so I'm just going to show the transitive dependencies. So what I have here, it's on 334. It has a dependency on the Duke dep, and it has a in-memory database. Other than that, it's just a simple Spring web app. And the code itself is very, very simple. I just have to reload a POM here. Let me see. So I do have the Spring Boot application, which is just a Spring Boot application, and it has a RESTful interface. So I have this REST controller that has a post mapping where I can post a user, and from this user it creates a new account, and then stores it to the database. So that's kind of my business logic. And I can also just list all the users through this get users. The key here is that I'm doing some validation. So I'm doing the @valid annotation here on the user, and the user is just has the email field, and this email has the add email annotation that comes from Jakarta validation. So Jakarta validation is used by Spring, right? So I'm validating this object on the incoming request, and in the Duke dependency that I depend on, that's where I have the account class, which I have migrated now over to the Jakarta namespace. And this account is using the Spring data to store it. So this is all there is. But you may notice that I don't have the user class, because the user class comes from my transitive dependency in the Duke lib. So this is where the problem is. And if I look at the user, you can see it's using the javax version of validation. So if I run this application, I'll just compile it first. So you see that I'm using the latest. And then I'll run it. And then I'll exercise the API, just show you it is empty. It has nothing in the database. So if I post in here a Duke with an email here, it says user is valid, so it does some validation, apparently, and it stores it in the database. So what if I send in an invalid email? It still says user is valid, and I store it in the database, and I have now corrupted my data. And that's because the @valid is used, but the @email isn't discovered because it's looking for the Jakarta validation part of the Spring data. So this is the where you have something in the transitive dependencies that I have to fix. So I don't have the source code for this one. So let's do that, and I'll just stop it. And as you can see in my Duke dep here, that's where I have this transitive dependency on the Duke lib. So what I have to do is to get that jar so I can transform it using some of the tooling that we created for Jakarta EE. And there are two tools out there that are equally good. It's the Eclipse Transformer and the Apache Tomcat migration tool. And it depends which conference I am, which tool I'll demo. So 2 weeks ago, I demoed the Tomcat migration because I was at the Apache conference. And now here at OCX, I'll do the Eclipse Transformer. And the Eclipse Transformer you can find on the GitHub page for that project. So you can use it as a Maven plugin, as a standalone tool, or whatever way you want to use it. So what I'm doing is the standalone just executed jar. So the first thing I have to do is just copy this this jar from my Maven repository. So I'll just see if I can find it. Copy. So I'll copy it from my local Maven repository to this local folder. So I have it here, and I've downloaded this Eclipse transformer. It's just a jar. So I've downloaded it because I don't trust the conference internet. So I have it here on my computer. So I'll just run it. I downloaded it to my development tools folder. It's the org Eclipse transformer. It's version 0.50, and then the input is just the jar. So I'll run it, and what you see there is it creates an output file as well. And if I do compare these two files, let's compare archives there. You can see that the old dukelib has the javax validation, but the output file has the Jakarta validation. So it changes the bytecode for me. So I don't have to do, so the only thing I have to do is take this and make it available for Maven. So what I'm going to do is just install it in my local Maven repository. If you were in a company, you would install it in your company Nexus or whatever artifact repository you're using. So I'll just do the Maven install file, and then point to the output file, give it the same group ID, artifact ID, but I'll bump the version number. You can give it a classifier or something else. It depends on whatever you like to do. So if I now look at my Maven repository, I now have a version 2.0 there as well. And then I can update the POM file of my dependency to use version 2.0. And when I've done that, what I have to do is reinstall my dependency. And then I have to rebuild my application so it picks up the new version of that dependency. So if I now, let me see if I just did it correctly. Yeah. So if I now do run it, I can now do the, let me see there, the HTTP. So it's now empty again since I've emptied it. I'll do the Dux.com, the happy flow first. You can see it installs the Duke user in the database. And if I now give it a faulty address, it will say bad request, and I don't have crap in my database. So this is how you can use the Jakarta tooling for a Spring Boot application. So this is kind of neat as well. And when I did this talk at Spring I/O, they were, I wish I knew this tool when I did the migration. You can always, of course, do this migration manually. So let's show more. So it's very, you can see it's built on Jakarta EE. It has a lot of dependency on the Jakarta namespaces. But it's also other things. This is from the keynote at Spring I/O, where Jørgen talked about the Spring Framework 6, which is coming later this year. And they're already preparing it to use the Jakarta 11 APIs. So let's take a look at this is Jakarta 11. So you can see, continuing from 10, we're doing a lot of updates in 11 as well. We're even adding a new specification for data. So I'll paint everything blue, and then I'll start adding where Spring kind of lays over. Funny story about this. I did this at Apache, where I showed the relationship with Apache, but then I used, of course, the beautiful red Apache feather color. But I realized halfway into my talk that it started looking like an election chart in a country over there. But but green, it should be fine. So mail is, if you're using mail, I mean, everybody uses Java Mail, or Jakarta Mail, as it's called now. So mail, if you're using Mail in Spring, you're most likely using the Mail API for Java, which is Jakarta Mail. Messaging. The Spring provides a JMS template and abstractions over messaging. So if Jakarta messaging is there, you can use it and use it more easily than with, you don't have to interact with the messaging or JMS as it used to be called, the messaging API directly. You can use the Spring templating mechanisms and use it as you would do all the templates in the Spring framework. And you would actually be using Jakarta messaging underneath without even knowing that you're using it. Concurrency, kind of the same thing. They auto-adapt to Jakarta concurrency if it's present. Or otherwise, they have other mechanisms underneath. But concurrency is used if it's there. But it's kind of abstracted away from the Spring developers. Servlet is probably the specification that Spring relies on the most. And you can just look at the startup of Spring Boot. It says here, starting Servlet engine, starting Apache Tomcat. And you can easily switch this to Jetty or Undertow or OpenLiberty or any other servlet container if you like. And the key thing there, it's the servlet container. So without the servlet, Spring wouldn't start. And Tomcat is the default when you start an application from Start Spring IO. And Jetty is probably the usual one you would use as an alternative. But as I said, you can use any servlet engine. So that means that if you have a traditional web application, like a Spring Boot application, probably if you do it the old school way, you have a Tomcat cluster in the basement and somebody is managing it, and you send them a file and they install it. And they have Tomcat 9 running, and you create a new Spring Boot 3 application and say, hey, just deploy this. They will probably do it. It will work. But it won't do anything. And they won't discover it because nobody tests, right? So they'll just start it and it won't do what you're expecting it to do in production. So what you need to do is ask them to actually install a Tomcat 10 or higher. Then it will work. Because Tomcat 9 looks for javax servlet, whereas Spring Boot 3 is using the Jakarta servlet. So this is the namespace thingy again. In Tomcat 10, it will pick up the Jakarta servlet, and Spring Boot 3 will work fine there. Of course, there are servlet engines that can support both namespaces, so then you won't have to worry about that at all. And Jakarta servlet is updated in 11, so that will be picked up by Spring. And it's already probably there, because servlet is released a long time ago. What they do in Servlet 6.1 is to remove security manager references. That kind of what we do all across the platform. They have some fine-grained controls over the redirects, so you can give it a custom status code. Previously, you would have to use the default. So it's probably not that relevant for a Spring developer, but if you want to do this kind of low-level servlet thing, you can. Persistence is another one. So everybody uses Hibernate. And Hibernate is the default implementation that you pull in with Spring when you use Spring JPA or Spring Data. So Hibernate ORM is everywhere in Spring, and it's probably already on the latest version. And what we did in Jakarta 10 was to add UIDs as basic Java types. So now we can use the UIDs directly without mapping if you use them in your database. Version 3.2 is coming in 11, and that is also probably already picked up in Spring. And that will be adding Java records as embeddable classes. I don't think you can use records as an entity yet, but as an embeddable you can do. And more relevant to Jakarta EE than Spring is that you can now use add inject for the persistent manager. And you can also configure it programmatically if you want. So you don't have to have the persistent XML if you don't like XML for some reason. But the most important thing here that is more relevant for Spring is that the deprecation of the old calendar date time stuff and replace it with the new, which is fairly old that as well, but no, we're finally replacing it. So now we can use the local time and local timestamp and local date and these kind of things. And It's deprecated, it's not removed, but it will be sometime down the road. So if you're using the old stuff, you better get over to the new or newer. WebSockets are extended by Spring. So whether, depending on which container we're running in, it will kind of elevate it to the most relevant protocol. So you don't really need to think about it, but it is Jakarta WebSockets underneath, and it will use it depending on which container you're using. Jakarta validation, we already demoed that one. And the Hibernate validator is pulled in by Spring. So that is an implementation of Jakarta validation, or Jakarta Bean validation, as it used to be called. We're kind of trying to condense the names. So Jakarta validation is easier to say than Jakarta Bean validation. It's shorter. And Jakarta validation 3.1, Jakarta validation wasn't updated in 10, but in 11 we're doing an update, and the update there is to support Java records. And so you can actually validate the records properly. It's actually there already in the implementations, but now the specification says that it should be supported. Transactions is sort of the same thing as with WebSockets and concurrency. It's supporting the Jakarta transactions underneath, but you don't have to think about it as a Spring developer. There is a programmatic API, or you can use the declarative style there as well to simplify use of transactions. So it's made easier by some extension on top from Spring. RESTful web services, this is kind of maybe not the one you would think of, because they have the REST controller and the Spring MVC support for RESTful web services, but you can actually use Jersey if you want to. So you can configure to use Jersey as a filter rather than use the servlet underneath. So you would add this Jersey config, and Spring would filter it through and use the Jersey mechanisms rather than the servlet-based approach. JSON binding is auto-configured to Eclipse YASM from Spring. Annotations and dependency injection, kind of related. They were defined by JSR 330, which is making it possible to use add inject and add auto wired interchangeably. So you can use add inject in Spring as well, or auto wired. It doesn't really matter which one you use. And that's because of JSR 330. So if we map all of these, you can see it becomes fairly green. It's about half of the specifications are more or less directly or indirectly used by Spring, and I probably could paint some more of them green as well. But this is how far I got when I researched this. So if you look at, for example, the pages, the standard tag libraries, and authentication, all of those are implemented by Tomcat. So since they have Tomcat as their servlet engine, you also have these APIs available. So they could have been green here as well, but there's no direct relation to Spring. So what about the other way around then? If you look at beyond Jakarta EE 10, it's 11. No surprise there. And 11 is supposed to be released very soon. I think we will have core profile out very soon. The TCK is available and everything is started getting prepared. We will see about the platform and web profile, hopefully by the end of the year, but there are still some work going on with the refactoring of the TCK for the platform. So let's hope for Q4. We're establishing a release cadence now of 6 to 9 months, maybe a year after an LTS of Java. So when Java 21 came out last year in September, this year in 24 we want to release Jakarta EE 11. When Java 25 comes out next year in 25, no, it will come out then in 26 we want to do Jakarta EE 12. So 6 to 9 months after, like around summer in 2026 is where we plan to have 12. So that means that we've done 9 in 2020, 10 in 2022, 11 in 2024, and 12 in 2026. So we have a 2-year release cadence of Jakarta EE, and that's kind of where we're aiming for. We're adding data in Jakarta 11, and data is very much inspired by Spring Data. It standardized the repository pattern for data access. And if you look at this code, if you're a Spring developer, you would say, yeah, I know this. This is Spring Data. But it's not. No, it's Jakarta Data. And it's exactly the same API. So I can understand why you would think it was Spring Data. But we are doing something more. We're doing more than Spring Data, so it's a little bit more stuff. We have the Jakarta Data query language as well. And the Jakarta Data query language, or JDQL, is a subset of the Jakarta persistence query language, which is JPQL. And here you can write queries as annotations as well. And this is and there are much more. You can add find, add select, add whatever. And these annotation based are actually a little bit safer, better to use than use the method names. So it's more concise. You have more control over what's actually going on. So it's a very good extension to Jakarta Data that currently Spring Data doesn't have. But maybe in the future they will pick up this as well, because when we have two APIs that are so similar, maybe Spring Data will implement Jakarta Data. Who knows? Or maybe they will just use the Jakarta Data implementation, hibernate, and scrap Spring Data. We'll see what happens. But it's interesting how Spring depends on Jakarta EE, and when they do something good, we bring it back to Jakarta EE and standardize it. There's also an opportunity there to create a Jakarta Data implementation. If you're interested in being a hero in open source, go to Apache and create a Jakarta Data implementation project. It should be fairly simple to do. You can look at how they've done it in Hibernate or in OpenLiberty to do the implementation and just do it. And you can also do it at Eclipse Foundation. Could contribute to, for example, the Eclipse Links project, or a standalone. Jakarta NoSQL standardized integration with NoSQL databases. And an interesting fact there, the implementation of Jakarta NoSQL, this is a standalone specification, it's not part of 11, it may be a part of 12, we'll see. So what's interesting there is that the implementation of Jakarta NoSQL, which is called Eclipse JNoSQL, just to make it a little bit less confusing, that implements Jakarta NoSQL and Jakarta Data. So you can use Jakarta Data with other things than persistence, the regular persistence. Jakarta RPC is standardizing gRPC within Jakarta EE. This is a project that is in desperate need of help. So if you know the gRPC protocol, please do join them, help them, provide some traffic on the lists, get them going. There is some code already contributed, so it's just to pick it up where it's left. And the goal is not to replace gRPC in any way. It's to make it easier to use. So it's kind of just make it more available for Java developers. Jakarta 11 will be based on Java 17. Remember, 10 was based on 11, but we were testing it on 17. So this is based on 17, but we're testing it on 21. And it already runs on 23. So we're kind of looking forward. We're covering those that are on the edge of Java versions, but we're also keeping the tail. And Java 17 is the obvious choice. We were thinking of doing, you have to be on 21, but then we've lost a lot of people, and Spring would have been forced to either not go on 11 or backport or force everybody on 21. And there are so many still on 17, so I think this is a very good decision made for the community. But we can use 21 or 23 features if you like. So to sum up, Jakarta 10 is here. Jakarta 11 is coming. And we have a 2 years release cadence of these releases. I hope this gave you a little understanding how Jakarta is relevant to Spring and vice versa. Because as we said in the beginning, Spring builds on Jakarta EE. And If we lay it over, you'll see that it's about half the specifications are more or less directly or indirectly used by Spring Framework. And if nothing else convinced you, it's the namespace change from javax to Jakarta. So J2E brought Java to the server and inspired Spring. Spring simplified and inspired Jakarta EE. And Jakarta EE develops a foundation for and is inspired by Spring. If you want to know more about Jakarta EE, you can go to jakarta.ee. If you want to get started with Jakarta EE, go to start.jakarta.ee. If you want to hear me rambling about Jakarta EE, go to my blog. And if you want to look at that migration code, it's on my GitHub called Jakarta EE Spring. I also have a course available on LinkedIn Learning, so if you want to learn about Jakarta EE, it's about an hour and you get a nice badge on LinkedIn. You can go to the LinkedIn Learning and just Google the Jakarta EE overview course. And with that, I thank you very much for listening, and I hope you enjoy the conference. And we have like minus 45 seconds for questions, so a couple of questions. Yes. Thank you very much.